Geotrig, this is day 3 of lesson 1. We need to continue on with the writing the equations with complementary and supplementary angles. So do a real quick recap here. Remember that when we're talking about a complementary angle, we're talking about, hey, it's 90 minus A. So if we're saying what's the complement of A, it's 90 minus A. If I'm talking about the complement of angle B, it's 90 minus B. The supplement is 180 minus A. So we got that far yesterday, or last time we met. And so today we need to actually write the equation so we can find what A is. So what we're going to do is that we're going to read it now. We're going to take out some of that other extra stuff, like what does this mean, and the 90 minus A stuff. So let me shrink this down to what we're supposed to look at, not everything that's there. Take out the unnecessary things. So some of those unnecessary things is all of that. The other one is that. So that's what you should be reading. The complement of angle A is 20 degrees less than half the supplement of angle A. Find the measure of angle A. That's where the equation comes from. But you need to realize the stuff that I erased, that's what it means to be the complement and the supplement. Okay? So, okay, the complement of A. What was the complement of A again? So it's 90 minus A. So 90 minus A, in parentheses, please, is, everyone, is means what? Equal. Now, do we talk about 20 less than, to be more than or less than something? I think we spent a lot of time on that, right? So to be more or less than something, you need to know what that thing is, right? That thing that you're going to be greater than or less than, you're 20 less than something. Which means at the very end, can't you just write minus 20? But you need to figure out what is that thing that you're being less than. In this case, it's half the supplement. So what does it mean to be half the supplement? Half means 1/2. Supplement means, I don't know how else to say that. 0.5, 1/2. Right? Half. Half of what? The supplement. What's the supplement of A? 180 minus A. At this point, this is what, an Algebra 1, maybe an Algebra 2 style problem? I should not have to work this whole entire problem out with everyone. It's one equation, one variable. But we're going to do that today. Today, on the left-hand side, we got 90 minus A inside parentheses. Do I need those parentheses? No. So let's get rid of them. Equals, do I need the parentheses on the 180 minus A?
Yes.
Why?
Distribute.
Got to distribute otherwise. So let's do that. What's half of 180?
90.
Ooh, okay. And then half of negative A is negative 1/2 A. And does the negative 20 go anywhere? So it's going to go along for the ride. So is everybody okay with the first move? I did a little bit of something on both sides. That's okay. They're completely separate from each other. I think at this point, I would like to gather up like terms. Where do you see some like terms? 90-20, right? What happens when I combine those two up? I get 70. Did not do anything on the left-hand side, but I got 70 minus 1/2 A. The biggest key or rule when solving an equation is what again? It's like our golden rule. Do unto others as you would want done unto yourself. So in this case, what you do to one side, you do to the other. What do we want to do? Give me a feasible option. Say it. Go ahead, Angel.
Subtract 70 from both sides.
Is that okay? Subtracting 70 from both sides.
Yeah, why not?
Yes.
Yeah, why not?
Yeah, why not?
What if I said, that's probably not the move I would make, but it's a good move.
I make.
Okay? What I think, guys, is not always the right answer, okay? It's not the only way. I think there might be a more efficient way for us than doing that first. I think it's going to have to happen. What's on both sides that we generally don't like to have on both sides?
Right.
A's, the variable.
Add the 1/2 A.
Okay, so do I add 1/2 A to both sides to get rid of the negative 1/2? Or should I add A to both sides to get rid of the negative A?
Rid of the negative A.
I would get rid of the negative A. Why? What's so special about that one versus the negative 1/2?
Negative.
They're both negative.
It's alone, Marty.
Huh?
It's alone.
It's alone.
Yep.
I think I would want something more than that. Because it does not matter. I could add 1/2 A to bring this one over there. Or add 1 A to bring that to the right. It does not matter. It won't matter. They're both correct. Another question that I have for you, do you like working with negative numbers?
No.
No, not if I don't have to, right? So what's the rule when moving variables that doesn't guarantee I'm going to be positive, but gives me a better chance? Always move,
Biggest.
no,
Smallest.
smallest variable. Which one's smaller, negative 1 or negative 1/2? It's negative 1. So I'm going to add A to both sides. In this case, it actually results in a positive answer, and that positive answer is what? What's a negative 1/2 plus 1? 1/2 A. I'm just going to keep going in the downward, here. I'm going to go right past the words. It's okay. The next step would be, now it makes sense to move the 70, right? So now, subtract 70 from both sides. Notice what I'm doing. I'm showing my work. It's a novel idea, isn't it? Show your work. Every time. Every step. If you think, hey, should I show my work? Yes. These are gone. 20 equals 1/2 A. To get rid of 1/2 A, I'm going to what?
Multiply by the reciprocal.
Multiply by the reciprocal or divide by 1/2. Same thing. And that means multiply it by 2. 2 times 20?
40.
The 2 and the 1/2 cancel. A is 40.
Done.
Pretty excited about that, right? Now, what I want you guys to do is I want you to use what we just did in that first problem, and I want you guys to try the second problem on your own. But try not to use the first problem for every single step. Okay, the next one. 3 times the complement of an angle A is 40 more than the supplement of angle A. This is the classic problem. There's no extra stuff in there. They're not telling you what a supplement is, what a complement is. You need to know it now. So, 3 times the complement of A. What does it look like? Not everyone at once here. 3 times the complement of A.
Is it 3 in parentheses, 90 minus A? In parentheses?
Yes, it is. Thank you. That is 3 times the complement of A. Is, everyone, equals 40 more. To be 40 more than something, you need to be plus 40, but at the end. What is the thing that you're being more than?
180 minus 8.
180 minus A. Do I need anything else?
No.
I don't think so.
Okay, so on the left-hand side, are those parentheses important?
Yeah.
Yes.
Because I need to.
Distribute.
So what's 3 times 90? 3 times negative A. Equals, do I need those parentheses? I'm getting rid of them. Plus 40. Me personally, I like to gather up like terms before I start messing one side to the other, so I have to combine the 180 and 40. What would that give me? 220. So everybody good to that point? They like it? That one was pretty straightforward, huh? Not too bad of an equation. Hey, I got a question. Can I add b to both sides right now? B. Could I add b to both sides right now?
Oh, it's B.
No, could I add b to both sides?
Sure.
Why not?
Yeah.
What I'm doing to one side, I'll be doing to the other.
That's a good point.
Can I multiply both sides by 10?
Yeah, sure.
Sure, but do I want to do these things?
No.
Okay, so don't do that, right? But I'm just trying to prove a point that you can do anything you want as long as you've done it to the other side, right? Okay, so what variable am I moving next? Negative 3a. So to get rid of a negative 3a, do the opposite. Add 3a. So these are gone. So 270 equals 220 plus 2a. And then subtract 220. So I end up with 50 equals 2a, or a equals 25. Okay, the next one, we're going to talk about vertical angles. Hey, look, you got a picture there with some crisscrossing lines. We got, bless you, 65 on the top, z over here, y in the bottom, and x. What could you possibly predict about angle y?
65.
Why do you say it's 65?
Complementary.
Ooh, I wouldn't say, don't throw complementary out there. It's not complementary. You got to be careful, yes. Doesn't it look like this angle here and that angle there look pretty close to being the same size?
Yeah.
And would you guys also say that this angle and that angle look to be pretty close to the same size?
Yeah.
It's because they
They are.
are the same size. Okay, I'm going to take all those angles. Oh, okay. Well, there are some things, guys, that we could talk about this book. This is a diagram. You can safely assume that those lines are, no, they are straight.
I was thinking about the angles.
Right? Okay. Now, if you have a straight line that is intersected by another straight line, well, then these angles that are straight like this or like this to each other, they will always be the same. Those are called vertical angles. So, these are called vertical angles. Vertical angles are blank of each other. What? Give me a word that we can use to say we know those are vertical angles.
Opposite.
Opposite. I like it.
Okay.
They're opposite of each other. Of the crisscross, right? Opposite angles. And they are blank in their degree measure. Same. Maybe use a fancier word.
Cool.
Congruent. They are congruent. They are the same. They are equal. Cool? Hey, look at X and Y. What do you think about those? They are the same. Oh, wait, X and Y. Never mind. Never mind. Let's back that up. Back it up. Erase it. Okay? Sorry. X and Y. Here's X and Y. There's X. There's Y. Hey, what are those angles? What do they form, guys? Together.
180.
180 because they form a what kind of angle?
Supplementary.
They form a
Straight line.
straight angle. And straight angles are 180 degrees.
Yeah.
So x plus y would equal z plus y would equal z plus 65 would equal 65 plus x would equal. Wait a minute. If they seem to add up to 180 on any particular straight line, right? And angles that are opposite each other, those vertical angles are the same. Could you find in part 4 x, y, and z?
Yes.
Right off the bat, what's y? 65. So y equals 65. How do I find z or find x?
180 minus 65.
So let's set up a little equation, guys. Which variable do you guys want to use? Or find? X?
Z.
X plus 65 is equal to? 180. So x has to equal minus 65 minus 65. What do you get? 115. Now wait a minute. But x is supposed to equal
Same.
z. So x and z both equal 115, and y is equal to 65. So you have to know your vertical angles and your straight angles, or the sum of any straight angle or angles that add to a straight angle equal 180. Questions? Your homework, lesson 1, day 3, page 12. 1 through 3, angle problems. 17 and 18 are a little bit more of the definitions. And 20, I forgot what exactly it was, but it's a fun one. So therefore, 1 through 3, 17, 18, and 20. Have a great day.